Good morning, everyone. Welcome to the class on investment management, where we are discussing the previous year questions. So, every session will do only one problem related to the previous year question paper of investment management. And today we are going to discuss this question which came in July 2018, which is of 8 marks. So, this question is like there's a financial analyst. Uh, uh, there's a financial analyst and the financial analyst is analyzing two investment alternatives A and B, the estimate rate of returns and the chance of occurrence for the next year is given to you, like with in term of probability that data is given to you. Okay, everyone, so what you have to determine, you have to determine the expected rate of return and the standard deviation of A and B, so that we have to determine here. So in order to do this, what is the formula what we'll follow to expected rate of return? So when we talk about expected return, when we talk about expected return, so the formula what we have to follow is sum of pi into ri. This is a formula what we have to follow for the expected return. Okay, and then the formula for the standard deviation, the formula for the standard deviation what we need to follow. So the formula for the standard deviation we have to follow is under root of summation of pi into ri minus er whole square, where er is the expected return, where er is your expected return. This is the formula of standard deviation which we will apply here to get the answer. I hope everyone is clear this much. Any question, anyone? So based on this, if I write down the a statement like this, so I have point 2, point 6, point 2, point probability has point 2, then point 6, then point 2. The sum of total probability should be equal to 1. Point 2, point 6, point 2. Then a rate of return A 22, 14, and minus 4. Return on A, return on A, return on A, that is equal to 22, 14 minus 4. 22, 14 minus 4. That is a return on A. Okay, so then this is a return on A. So if it return on A, so similarly there's a return on given on B. So the return which is given on B, so the return given on B is 5, 15, 25. That is 5, 15, and 25. Return on B 5, 15, and 25. Return given on B 5, 15, and 25. That is a return given on B. So what you can do, you can find expected return. You can find expected return, okay, on A. So for that, multiply the probability with the return. 22 twos are 44, so you get 4.4. Okay, and 14 six are 8.4. Then minus 4 into 2, so 4 twos are 8, so minus 0.8. So 4 twos are 8, so minus 0.8. So you can find the expected return. So you can find the expected return. So the expected return on A is 8.4 plus 4, 12. Then it is 13.2. 13.2 minus 0.8. So 13.2 minus 0.8. That would be how much? That would be 12.4. So the expected return is 12.4. So the expected return is 12.4. So then the expected return, then the expected return on B, then the expected return on B. So that is 5 into 0.2 means 1%. Okay, 5 into 0.2, 1%. 15 sixa is 9%. 9%, 15 sixa is 9. 25 tuza, 25 into 0.2 means 5%. 25 0.2 means 1 by 5. So 1 by 5 into 25, 5%. So the expected return is here is 15%. So you got the expected return on A and B. Okay, so you got the expected return on A and B. Now find the, this is clear everyone, write it down. I hope everyone done this much. Let me know anywhere any calculation mistake happens, anything like that, just let me know. So once you're done with this, once we are done with this, once we are done with this, then once we are done with this, then return minus expected return. So for A, return minus expected return. So R minus ER. So for A, better I should write. So RI minus ER. So for A, so A22 expected return is 12.4. So 22 minus 12.4. So um, so 22 minus 12.4, 22 minus 12.4, that is 9.6. That is 9.6. That is 9. That is 9.6. Then 14 minus 12.4 means 1.6. Okay. Then minus 4 minus 12.4 means that would be minus 16.4. That is Ri minus Er. Okay. Similarly, I do for B. That is Ri minus Er. Okay. That is 5 minus 15. That is what, minus 10. Okay. You all are in percentage. Then 15 minus 12.4. So then 13, 2.6, then it is 2.6. Then it is 2.6, 25 minus 12.4. So then it is 12.6, then it is 12.6. Correct, no? 25 minus 12 is how much? 13, no? Hmm. So 13, so 12.6. Anyone, any doubt? Anywhere, any calculation mistake, anything you want to highlight? Clear, everyone? Correct, everyone? Anyone have any doubt? 15 minus 15, which one? 1 minute, Harish. Okay, yeah, yeah, Harish. Thank you, Harish. So 5 minus 15 minus 10. 5 minus 15 minus 10. 15 minus 15, 0. Then 25 minus 15. Then 25 minus 15. That would be 10. Thank you, Harish. So 5 minus 15. 5. 5 minus 15 minus 10. 15 minus 15, 0. 25 minus 15, 10. So you got this. Then after that, what you're telling, sir? Then 12.5. It will come 12, sir. 12.5. Where's 12.5? You mean this? This one you mean, Harish? This is correct now. 4.4, 4.4 plus 8.4. This is 12, 13.2, 12.4 will come. Okay, fine. So we got for A. Now what I want, do the square of this for A. Do Ri minus ER whole square of this. Do whole square of this. 9.6 square. Do the square of that. 9.6 square. 9.6 square. 92.16. 92.16. 92.16. 1.6 square, 2.56. 1.6 square, 2.56. 16.4 square. 16.4 square. 268.96. 268. 268.96. 268.96. I hope this is clear with everyone. Then for B, Ri minus ER whole square. 10 square 100. 0 square 0. 10 square 100. Clear everyone? Okay, Yogesh. Hmm. So I hope this is clear with everyone. Okay, so we did the square. Now multiply with probability. Let me know anywhere, Harish, Sanjita, Chaitanya, Suraj, anywhere you feel any mistake and I'm doing just any calculation mistake, anything. So multiply for A, Pi into Ri minus R whole square. Expected return total is 12. Which one you are telling? Calculation mistake is there. You are telling for A, Yogeshwari, is it? Okay, so guys, let me check. So your first one is 4.4, Yogeshwari. First one is 4.4. Guys, small mistake was there in the expected return. So the expected return on A was 12%. So then RI minus ER, 22 minus 12 would be would be 10, 14 minus 12 would be 2, and minus 4 minus 12 would be minus 16. Okay, so then this value this value would be 100, then it would be 4, and this would be 256. Okay, so so we do the square of this. We did the square. Now we multiply with zero point 0.2. No, 100 into zero point 0.2. 0.2. 100 into zero point 0.2 means how much you'll get? 20, right? 100 into zero point 0.2 you'll get 20. 4 into zero point 0.6. 4 into zero point 0.6 means 4 into zero point 0.6. 2.4, and 256 into zero point 0.2. 256 into zero point 0.2. 51.2. Anywhere, any calculation mistake? This is zero point 0.6 and this is what, 3. This is 73.6. This is 0 0.2, 0 0.6, 0.2. 0.2, 0.6, 0.2. Clear everyone? Clear everyone? Then it is 100, 100, 0, 100. Then do the same thing. Do the same thing for B. Do the same thing for B. Do the same thing for B. EI into RI minus ER whole square. Do the same thing for B. Do the same thing for B. So 100 into zero point 0.2. 100 into zero point 0.2 means 20. Then this would be 0. Then 20. So this would be 40. Clear everyone? So the standard deviation on A, standard deviation on A, that is equal to square root of 73.6, and standard deviation on B is square root of 40. Eight point 579 and square root of 40, 6.324. Clear everyone? Okay, so we got the standard deviation, we got the expected return also. Okay, we got the standard deviation, we got the expected return also. So now what we have to do now, next thing is that if the financial analyst wish to invest half of the money in A, half of the money in B, would it reduce the risk? So what we have to find, so we found the individual standard deviation. So now I have to find like portfolio risk. Now I have to find portfolio risk. If half of the money you put in A, half of the money you put in B, means you have to find the portfolio risk, means standard deviation. 50% money in A, 50% money in B. So then you can find the formula W1 square sigma 1 square plus W2 square sigma 2 square plus 2W1 W2 into covariance between 1 and 2. So this you have to find. So now in order to find this, now in order to find this, covariance between 1 and 2, you have to use the formula. What is the formula? Summation of pi into rx minus erx into ry minus ery. This formula I have to use, the formula of covariance between 1 and 2. Clear everyone? So we already have rx minus erx. We already have ry minus ery. Okay, so I have rx minus erx. I have ry minus ery. I need to multiply them. Okay, so I need to multiply them with probability. So I need to multiply them with probability. So can I start? I know the standard deviations. Okay, everyone, I know the standard deviations. I just need to multiply them with probability to get the covariance. Okay, everyone. So I'm doing it here only. So multiply pi into rx minus erx, ry minus ery. Okay. So I'm multiplying them. So I'm multiplying them. Okay, everyone. So I'm multiplying them. So, so if I multiply them, means probability is 0.2. 0.2 into 10 into minus point minus 10. So 100.2. So 100.20% of 100. 100 into 0.2 means minus 20 you will get. Correct, right? Then 0.6 into 2 into 0, you will get 0. then 0.2 into minus 16 into 10. 0.2 into minus 16 into 10. So 0.2 into 10 is 2. 2 into minus 16 is minus 32. So you will get minus 52. So covariance between A and B, you will get minus 52. Is this clear, everyone? Clear? Any mistake? Any question you want to ask? Any doubt? The covariance between, you got the covariance between the stock A and stock B is minus 52. You got the covariance also. Covariance between stock A and stock B is minus 52. I think you got everything. So if I talk about portfolio risk, if I talk about portfolio risk, okay, if I talk about portfolio risk, okay, so if I talk about portfolio risk of stock A and stock B, so stock A and stock B, A and B, if I talk about A and B, so their weight, I'm putting equal money both of them, 0.5. Okay, so this is their weight. You can do the square of that, you'll get 0.25. Okay, so their standard deviation of A and B is 8.579, that is 8.579, and then it is 6.324, then it is 6.324, then you then variance of this, so the variance of this is 73.6 and 40, 73.6 and 40. Variance of this is 73.6 and 40, and the covariance and the covariance between them, and the covariance between them is minus 52, and the covariance between them is minus 52. So because covariance is negative, no, definitely the portfolio risk will decrease. So you can see that because the covariance between A and B, because the covariance between A and B is negative. So definitely, so the portfolio risk will get, so the portfolio risk will get decrease. Understand this? Because the covariance between A and B is negative, so the portfolio risk will definitely will decrease. Okay, everyone. So here, when you talk about the scenario, so here when we talk about portfolio risk, when we talk about portfolio risk, the standard deviation of portfolio, so that would be W1 square plus sigma 1 square, W1 square plus W1 square into sigma 1 square plus W2 square into sigma 2 square plus 2W1 W2 into covariance between 1 and 2. Okay, so the portfolio risk W1 square, so W1 0.5 square into sigma 1 square, sigma 1 square is 73.6 and 40, 73.6 plus 0.5 square into 40 plus 2.5 into 0.5 into covariance between 1 and 2. covariance between 1 and 2 is minus 52. So you can find the this. So this is 0.25 into 73.6 plus 0.25 into 40 plus 2 into zero point 0.5 means 1. Zero point 0.5 I can write as 1 by 2 into minus 52. So the variance of the portfolio. So 1 by 4. So that is 1. 33 means 8. 1. 18.4 plus 10 minus 13. So you will get is 18.4 minus 3. So you will get 15.4. That is the variance of the portfolio. So the standard deviation of portfolio square root of 15.4. 3.924. 3.924. This is the standard deviation of the portfolio. Let me know if there's any calculation mistake. Clear now, everyone? Everyone clear with this? Anyone have any doubt? Any question you want to ask? I hope everyone understood everything. So then wind up the class. Thank you, everyone.